Hi students, this is Ms. Cave with a lesson on scientific notation. Today in class we learned about how many stars there are in the universe, or we estimated that, and we came up with a very large number that would require many numbers after the decimal point. And so we learned that the best way to write this number would be using scientific notation. So the number of stars in the sky, or stars in the universe, can be written as 4 times 10 to the 22nd power. And that's a very large number. That's 4 million stars in the universe. Okay, let's look at our video notes. You should have this in front of you, and we're going to go through it together. Scientific notation is used to write really large, like in the instance of the number of stars in the universe, or really small numbers, like the size of atoms. It is done by using powers of 10. At any time during this video, if you feel like I'm going too fast, feel free to pause the video so that you can catch up in recording your notes. All right, so we have an example here at the bottom. This is the format of scientific notation. You have this first number, which is called the coefficient. And it's always a number, to be in correct form, it's always a number between 1 and 10. So this is 3 4/10, and that's between 1 and 10. And it can't be 10. It can be up to 9.99999. All right, and then we have our power of 10. We always use 10 as our base when we're dealing with scientific notation. And then we have this number here, which is our exponent, which tells us how far the decimal is moved. So this case, it's being moved 7 places, and in which direction. So to get the actual number for this, we would move this decimal 7 places. So I would move it 1, 2, 3, 4, 5, 6, 7, and annex my zeros. Okay, so now it's placed here. So I can go back. And so this number, 3 4/10 times 10 to the 7th power, is equal to 34 million. And this is another example. This is how you can go from scientific notation to standard form. And we'll look at more of those examples today. Okay, next part of the notes. So how do I go from standard notation to scientific notation? Well, the first thing I'm going to do is I'm going to place the decimal point so that there's one non-zero digit to the left. Okay, so let's look at an example as we go through this. So let's say we have, make my pen a little smaller. Let's say I have 37,000. We'll use a smaller number this time. Still big, but a smaller number than the ones we've used for numbers of stars in the sky. So the first thing we do is we move our decimal point. The decimal point always is here. Okay, so we moved it 4 places. So we're going to count the number. That's what I just did. We counted the number of decimal places the decimal has moved, and this will be the exponent of the 10. And so I'm going to write that. So that means that we have 3 7/10. Okay, I'm just working off this example, times 10, always 10 for our base, and then it's 10 to the 4th power because I moved it 4 places. Now I want you to notice something here. There are not 4 numbers in this, or 4 zeros in this number. I did not just take off the zeros and leave the number that was left. There are only 3 zeros and then one non-zero digit. So a lot of times kids think that I can just simply take the zeros off to simplify standard notation to scientific notation, or write it as standard notation to scientific notation, but that's not always true. Okay, a very large number will result in a positive exponent. So this was a large number. And a very small number, decimals, we'll be dealing with those in the next slide. A very small number will result in a negative exponent. Okay. So now let's look at what we do when we go from scientific notation to standard notation. Let's take a look at an example. So if I have 7 2/100 times 10 to the negative 6th power. Okay, so it says move the decimal point to the right for positive exponents. Okay, this is not a positive exponent, it's negative. So I'm going to look at number 2, move the decimal point to the left for negative exponents of 10. And again, the exponent tells you how many places to move. So this is a negative 6, so I'm going to move my decimal point 6 places to the left. 1, 2, 3, 4, 5, 6. And I'm going to put in my zeros. I can put one before. So 7 2/10 times 10 to the negative 6 simplifies to 7. There's my 7 and my 2. And then I'm going to put in these zeros. 1, 2, 3, 4, 5. Okay, so I'm going to double check that I moved it 6 places. 1, 2, 3, 4, 5, 6. Oh, I didn't mean to put that there. So this is 72. Let's see what the place value would be. Tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions. So this is 72 10 millionths. Very small decimal. And you notice that takes up less room on your paper to write it that way. Okay, so at the bottom of your page you have a couple of examples that we're going to do during the video. So the first one is converting to scientific notation, and what I want you guys to do is you can cut that part out. So you can pause the video and you're going to cut this into one rectangle because you're going to paste this in your notebook. Oops. And then you're also going to cut this piece out. And then you're going to write on the back of each of these flaps. So we'll do something on the front, but then you're going to turn it over and you're going to write the answer on the back. Okay, so let's go to this one first. Okay, so converting to scientific notation, again, my first step is to make the number. I'm going to place the decimal point so that the number is greater than 1 and less than 10. So my decimal point is going to go between the 4 and the 1. So right here. And then I'm going to figure out how many places I move my decimal. So this is 1, 2, 3, 4 places. So on the back of this, I want you guys to write, I'm going to write it over here, but on the back of this flap, and you can just cut right here or do that later. The scientific notation for this is 4 1/10 times 10 to the 4th power. It's a positive exponent. All right, and then the next one, I want the decimal place so that the number is, there's only one non-zero digit to the left. And so to do that, I would move the decimal point right over here. And then I'm going to count the number of places I move my decimal. 1, 2, 3, 4, 5. But it's a decimal. It's a really small number, so this is a -5. So now I want you to turn, lift up this flap, and on the back, you should have 4 17/100 times 10 to the -5th power. So that's how you convert to scientific notation. So now let's look at what we do when we convert from scientific notation to examples to standard form. So the first one, we have 3 200 times 10 to the 7th. So we're going to move our decimal point. It's a positive exponent. We're going to move to the right. The number is going to be bigger. It's going to get bigger because it's a positive exponent, where this one down here is going to get smaller. And so this, we're going to move our decimal point over 7 places. 1, 2, 3, 4, 5, 6, 7. I'm just going to write on this. And then on the back, I'm going to simplify that. So it's 3, 2, and then I have 1, 2, 3, 4, 5, 6 zeros. Notice I don't have 7 zeros. Because I moved the decimal point 7 places doesn't mean that there are 7 zeros. So we're going to put in our commas. So every 3 zeros, we're going to put in our commas. It makes it easier to read the numbers. So this is 32 million. And I'm going to double check again. Yeah, that's right. This next one, we're going to work this out. We're going to move it 5 to the left. It's going to be a really small decimal. So 1, 2, 3, 4, 5. And then I'm going to put in my zeros. Okay. And then I'm going to write the answer on the back of the flap. So it's going to be 0. And I have 4 zeros. So this is 23 tenths, hundreds, thousands, 10 thousands, 100 thousands, millions. Let's try that again. Tenths, 100, 1,000, 10 thousands, 100 thousands, millions. So this is 23 millions. All right, and so you should have that on the back, and I need you to bring these notes with you to class tomorrow. I will be checking to make sure that they were done, and we will glue them into our notebooks. Have a great evening.